Clearing your tracks on Linux. In this video, we will be exploring the process of how to clear your tracks on Linux. So again, we're going to be following the same methodology that we used during the clearing your tracks on Windows video. The main objective here is to again follow the best practices that I outlined in that video, whereby if you are transferring files onto a Linux target system, transfer them into the temp directory. Furthermore, if you are utilizing the Metasploit framework for exploitation and post-exploitation, do actually keep your eye on the actual artifacts that are generated by those modules and identify where those artifacts are stored. In the event that a Metasploit exploitation module or post-exploitation module provides you with a cleanup resource script, do essentially note down where that resource script is stored, so that when you approach the final phase of post-exploitation, you know where it's located and you can use it and run it on the target system in order to undo what you did, or to undo what that particular post-exploitation or exploitation module did. So again, we're just going to be following the same methodology, and I'll be highlighting a few important techniques that you can run or that you should be performing on a Linux system. But as I said, do keep in mind or do consider the rules of engagement and the actual stipulations that are highlighted within it in regards to what you can and cannot do on a target system, regardless of the operating system. So this video has a lab environment attached to it. We're going to be exploiting the target system, and then we can explore a few techniques, pertinent to Linux that are very useful in clearing your tracks. With that being said, I'll see you in the lab environment. All right, so I'm back within the lab environment, and the first step is to gain access to the target system. We can identify the target's IP address by typing in ifconfig and taking a look at the interface Ethernet 1. So this is the Kali Linux IP. The Kali Linux system is always going to be on the second IP within the subnet. So all you need to do is just copy this value here. In your case, it's going to be different, but just copy the value and change the 2 to a 3, and that's the target IP address. All right, so let me just copy that there. And in this case, the target system is running a vulnerable version of Samba. So we can actually confirm that by running an nmap scan on port 445. And I'll paste in the target IP. I'll change the 2 to a 3 and hit enter. And you should see that it's running Samba version 3. So we'll give this a couple of seconds. There we are. You can see that Samba is indeed running. So we can fire up the Metasploit framework console and load the appropriate exploit module that will provide us with a command shell session on the target system. So I'll give this a couple of seconds. I'll firstly set the global variable for the rhosts option to the target IP address, so that whenever we load a module, the rhosts option or value is specified for us, so that we don't have to specify the target IP whenever we load a module. So I'll just launch a search for all Samba related modules, and the exploit module that we are going to be using is this one right over here. So that's the is-known pipe name exploit module. So I'll say use, paste that in there, and if I show the options, you can see that the target IP is already specified for us. The target port or R port is specified correctly as port 445. We don't need to specify the SMB folder or the SMB share name. We can type in exploit, and this should provide us with a non-interactive command shell session, which we can then upgrade to a semi-interactive bash session. As you can see, that is the case. So I'll say bin bash I. And in this case, we gain access to the target system with root privileges, which means we do not need to elevate our privileges. All right, so now that that is done, we can actually explore the first guideline or best practice, and that is whenever you are transferring files onto a Linux system, always store them within a centralized directory. And as I mentioned in the previous video, the best directory is always the temp directory. In the case of Linux, the temp directory is called temp. In the case of Linux, if I navigate to the root of the file system, the name of the temp directory is called tmp, and in most cases, a Linux system will always have the temp directory available. So I'll navigate to the temp directory, and there you are. and you can see it doesn't have any files in it. Now, do keep in mind that the temp directory is exactly that on both Windows and Linux, in that once the system is restarted, all files within the temp directory will be deleted. So while I do encourage you to transfer files to the temp directory, be aware of the fact that if you're performing a penetration test over a couple of days to a couple of weeks, then whatever files you have transferred into the temp directory will be deleted once the system is rebooted. So do keep that in mind. And that's also another good thing, because no traces or artifacts that you have utilized or you have transferred over to the target system can be found. So again, as I said, if we wanted to upload a file to this directory, we could either through the manual technique of setting up a web server and utilizing the wget utility, or we can utilize or upgrade this command shell session into a Meterpreter session and upload files directly using the upload upload command that Meterpreter provides to us. The next, and this is very important, which I'll not be showcasing because it's not really relevant now, is going to be the Metasploit framework exploit and post-exploitation modules and the artifacts that they generate. Given the fact that I've already explored how to utilize the cleanup resource scripts, I'll not go through that. But again, what I wanted to point out is that, most of these modules will generate, quite a few artifacts. And in the case of Linux, there may be an issue with cleaning them up. So you may need to clean them up manually instead of relying on the resource scripts. Now let's talk about Linux specific, techniques, right? So one of the cool things with Linux, and let me just navigate to the home directory of the user, or of the root user. If I list out the contents of the root user's home directory, you will see that in this case, we have the bash rc, which is the bash rc file, which is a configuration file for bash. It essentially stipulates how bash should work, and then of course you have a few other dot files and folders for configuration for the configuration of services, like the SSH directory, which we already explored. Now in this particular system that we have just exploited, the bash history file is not configured, right? Or is this particular version of bash on this target system has been configured to not store a history of commands in the bash history file. Now, on most Linux systems, you will typically find a bash history file. So the file will be .bash_history, and that file stores a history of all commands that you've typed into bash, from whenever the system was installed, right? And again, this can be limited or customized to only display the commands that were written or typed in over the last 1 week or 1 month, etc. And this is typically used by system administrators as a security mechanism to see what users have been doing. So every user account within their home directory has a bash history file. Now, as I said, in this particular case, the system is the way bash has been configured on this system is that whenever a user logs in and logs out, the bash history file or the history for that session is deleted. So I'll give you an example here. Let me type in a few commands, right? I can say cat etc, we can say cat etc password, and I can type in, uname r, for example. There we are. So we've typed in a series of commands. Now, from an attacker's perspective, you might be thinking to yourself, does anyone know what I'm typing in? Can this information be identified at any time? After we've compromised the system, or when an administrator is or an incident responder is trying to identify what was done on the system? The answer to that is yes, they can. They can easily identify the commands that have been inputted or essentially keyed into the system via bash by taking a look at the bash history file. Now, as I said, in this case, we do not have a bash history file, which works to our advantage. However, on most Linux systems that you'll compromise, you will find a bash history file. All right. Now, you can access or essentially view the history of commands that you've typed in for the root user within your current session by typing in history. So if I hit history, you can see that it displays a list of commands that I've entered chronologically from the time I logged in. You can see I navigated to the home directory of the root user. I ran the etc password command. I listed out the contents of a few directories here and there, etc., etc. And if I ever exit or log out from this session, in this particular case, this history will be deleted. Now, on most Linux systems, this will not be deleted. This information will be stored as is in the bash history file. All right, so what you typically find is within the user's home directory, there will be a file called bash history, and a good, measure or rather technique to use, and this is not really important in the context of a pen test, is to delete the specific commands from the bash history file that you typed in, or that may indicate to an administrator that the system has been compromised. For example, if they see a command whereby we are utilizing wget to download an exploit from a server, then that's something that could, essentially set the alarm bells, light them up on fire, and that is an indicator of compromise. So instead of deleting the contents of the bash history file, I would always recommend that you delete the specific commands that you typed in. That way it looks, or actually it doesn't look like someone has actually cleared it up. So an example of this would be, and I don't think that we have a text editor on the target system, so if I type in nano and vim, for example, you can see that it's not installed. But what I could do is I can just create the file. So I'll say touch, and this is how the file would look. So bash history. And as I said, if I list out the contents of the home directory, this is how the file would look. You can see it doesn't have any data within it. And if I echo, for example, I can just specify a test command here. So let me just type in history. And I can say echo. Let me just try and show you what this would look like. I can say 1 and, cd, for example. Let's say someone navigated to the temp directory. And I'll say I want to output that into the bash history file. So what an administrator would typically do is if they cat the contents of the bash history file, they'll be able to see a series of all commands, a list of all commands that have been typed in. And in this case, they'll be able to see, the commands that you have typed in. So there's two ways of clearing the bash history. As I said, you can go in and delete individual lines or, commands that you typed in, or you can type in the history -c command to clear the history. So when I type in history now, you can see that it's only displaying the history command. So this is something that I recommend that you do after you're essentially done on the Linux target system. It's just a good security measure to perform. Now, as I said, in the case of Linux, the process essentially mirrors the process on Windows. The most important thing to note or to keep in keep in mind is whether or not you're using the Metasploit framework for exploitation and post-exploitation. Secondly, if you're transferring files, have a centralized location for them that in a directory that is not frequently accessed. And a good example of that is the temp directory. And of course, when you're done with the system, make sure to essentially get rid of any traces that you were on the system. So that involves modifying or deleting the bash history file, or just clearing the bash history itself. As I said, in this case, let me type in a few commands here. I'll just, I'll just type in a few test commands. And if I type in history, you can see that those commands are logged. However, if I exit, and let me just terminate this session, and let me try and gain another command shell session once again. Let's see if it provides us with the command shell session. There we are. So I'll say bin bash I. And if I type in history, you can see that that data is still persisted. And this is something that can be very dangerous or very detrimental during a pen test, especially if there's an active blue team on the other side that are trying to identify any indicators of compromise. So whenever you're done, just clear out your history. And if I now exit once again, let me just exit. And if I, I'm just going to run the module once again. I'll just say exploit, and I'll just open up a bash session once again. Bin bash I. If I type in history, you can see that in this case, for some reason, the actual history file is not being cleared, but that is primarily because, let me navigate to the root of the C drive here. If I take a look at the bash history file now, and this is something that I didn't think would work, primarily because it was disabled. But you can see that once I created the bash history file, it's now storing all of the commands within the bash history file. So as I said, if you want to get rid of the history now, what you can do is you can say cat dev null, and you can then clear it out and specify that you want to redirect that to history or to the bash history file. So if I now say history, it's still displaying that, and if I say history clear, let's see, history once again, yeah, there we are. So that's cleared now, and cat bash history, it should only be showing the commands that I typed in. So there we are. So that is how to clear the bash history. As I said, in this case, there was a bit of an issue because I created the bash history file, and that consequently made bash essentially use that file for storing the history. And once we cleared the history then, and got rid of the content within the bash history file, the history was essentially cleared. So as I said, this was an unorthodox example. In most cases, the bash history file will already exist. In that case, you can run the following command to essentially clear it, and you can then run the history clear command as well. So that is going to conclude the practical demonstration side of this video. All right, so that concludes the clearing your tracks section of this course, and that is the final section that we are going to be covering within this course. So now that we've essentially gone through all the course material and the labs, we can move on to the final video within this course, which is going to be the course conclusion, where we'll essentially be taking a look at what we've learned so far, and essentially comparing our learning objectives that we highlighted in the introduction to the course, and seeing whether we've essentially hit all of those marks. With that being said, I'll be seeing you in the final video.